Hi, and welcome to Machine Learning on the Edge. I'm Zach Shelby, co-founder and CEO of Edge Impulse. We're finding that data and edge compute are really driving new innovations for real industries. And this is thanks to brand new innovations in the space of edge computing. On this show, we're going to talk to industry and business and technology visionaries about what's happening in this industry where machine learning meets edge compute. Today, on our first episode, we're really lucky to be here at the Computer History Museum with our first guest, Simon Segars.
Hi, Zach. How's it going?
Thank you. Very well. Simon was the long-term executive at ARM, board member, technology visionary, and helped create a lot of the technology that we have right here in the Computer History Museum. Recently, Simon joined the board of Edge Impulse, and we got to talking about all the amazing things happening in the industry. So I invited Simon to join our show. And right here behind us, we have the BBC Micro, among many other amazing pieces of computing equipment. Tell us a little bit about the journey from the BBC Micro and Acorn computers to ARM.
Yeah, well, thanks for having me here today. We are in this very, very cool place. I've been here a number of times, and it is stocked full of very, very fun bits of equipment that really do take you down memory lane. Seeing all of these 8-bit computers here is, really does trigger memories for me. A lot of these computers were a lot of fun and certainly played a role in my life in getting interested in computing and technology and everything. And the BBC was a huge component of that. That was introduced into the UK market as an educational tool. The BBC wanted to help teach the UK public about computers, so they commissioned the creation of that. The team at Acorn got together and built it. It's a fascinating story of get a bunch of really smart people together and have them build something, and it all came together at the last minute. But it turned out to be, an incredible computer. And one of the things that I loved about it was just how robust it was. I couldn't afford one at first, but when I eventually got one, they were in lots of schools around the UK. I'd got to use them at school or with friends. And it really helped teach me a lot about computing because it was such a kind of basic machine. You could take it apart, you could see what was on the circuit board, put it back together, and it still worked. That always surprised me, and it always, I think, made my parents relieved when I put the screwdriver down, switched it on, and it still worked, because as I say, they were not cheap. So, that was a fantastic piece of equipment, really groundbreaking design. Computers got more sophisticated, semiconductor processors advanced, microprocessors were getting more powerful, and the team at Acorn wanted a more advanced microprocessor to power their next generation of computers. They couldn't find what they wanted, so they thought, hey, how hard can it be? Let's build a microprocessor. Read about all this RISC stuff that's going on, let's design a microprocessor. So they did. And that led to the ARM1. Again, groundbreaking design, very small, very power efficient, very efficient in its use of memory as well. And that was then the CPU that went into the Acorn Archimedes series of computers. I got to play around with those when I was at university, and it was like, wow, this thing's such unbelievably fast. Little did I know, in parallel, lots of stuff was going on in Acorn. And it got to the point where the company couldn't really afford to have this R&D team building microprocessors, so they looked for a partner. Apple came along. They wanted a microprocessor for the Apple Newton. There's one of those over there as well. Again, very cool. Got together, decided to form this joint venture, and ARM, the company, was spun out of Acorn. I joined a couple of months after that moment in time, 16th employee, and it's been a fantastic journey since. We've made these things more and more energy efficient, with higher and higher performance, and there are now billions and billions of them out in the world. It's been a fantastic journey.
It's an amazing journey of developers creating new technology on the tools that we engineers provide for them. And that brings me back to many conversations we've had about the role of the developer, the rise of the developer really in the technology industry. And I can see how ARM enabled so much new silicon innovation, but what's happened more broadly with developers? We used to think of developers as following orders, right? Somebody decided to buy a piece of technology and then the developers marching orders to go make it work. But that's changed over the last couple decades in a big way. How have you seen this like intersection of hardware and software and the developer?
Yeah, well, I think what's happened is electronics has become much cheaper, much more accessible. Again, that BBC Micro, when they first came out, they were gold dust. You had to find a teacher that would let you into the school lab, and they're worried that you're going to break it. Very inaccessible. Now you can get a microprocessor that's got orders of magnitude more performance than that does for a couple of dollars on a circuit board. Plug it into another computer that, again, is really inexpensive. And so you've got this situation where anyone who's interested can get hold of this technology. So that's been a trend that ARM helped certainly drive, and it's a trend that ARM has benefited from. Because when you can put technology in people's hands, you kind of get out the way of innovation. Like you said, it used to be the case that here's some kit, go and build this thing, this is the spec, off you go. Now it's a case of, like, if you've got a good idea, you can get all these bits of hardware, plug them together, install some software, download it, and you're really only constrained by your imagination of what you want to build. So the situation's completely changed. And that innovation that comes about that you weren't expecting. Again, we saw this in ARM all the time. We designed this thing thinking about some end market. Then you found somebody used it for something you didn't anticipate at all. And you go, well, that's interesting. Because they've done that, well, why don't we do that? And you end up in this virtuous circle where the developers, the application developers, the software developers, the hardware developers pull through technology, and you get this fantastic feedback loop that leads you to build more and more, and the two things just reinforce each other.
Thinking about the accessibility of technology, how much would the BBC Micro cost in today's dollars?
Oh, I worked it out one time, and I can't remember, but they were about £400 in 1980 something, 1985.
$1,000?
So yeah, it's
$6,000?
not cheap. I mean, when you think about what you can now get, it's quite incredible.
BBC Microbit, $15.
Yep.
Arduino Nano BLE Sense, $20. Amazing what a developer now can do with this. Almost a supercomputer.
Oh, yeah, relatively speaking, absolutely, yeah. And the memory is the other thing. I mean, the BBC Micro, I think, has about a couple of kilobytes of memory. Yeah. Now, memory is limitless.
Now, that brings me back to my early days working with the Internet of Things. And 8-bit and 16-bit microcontrollers were really a major barrier to us bringing new technology into the space. We were working with the Internet protocol stack, of course, on microcontrollers for traditional control industries. But what we found is that a lack of cryptography and security was a major barrier to us bringing the technology in. And the 16-bit microcontrollers just couldn't keep up with the type of cryptography that we needed. In comes ARM. 32-bit ARM architectures actually solved that problem. Around the mid-2000s, we started seeing new ARM designs coming into the microcontroller space. Now, I find it really interesting that we were able to build this technology in, take advantage of the new wave of ARM architecture. What's happened in the machine learning world? We've seen the rise of cloud AI, which showed us that machine learning is absolutely possible to solve amazing problems, although it's just gotten bigger and bigger and bigger. Things like GPT-3 and now DALL-E are massive, right? Yeah. Not going to run that on a piece of edge compute. At the same time, we saw an amazing trend starting about 6-7 years ago with ARM research, looking at the opposite end of TinyML. How has that journey come together to enable this new wave of machine learning on edge compute?
Yeah, I mean, those first IoT devices, when people started using the term the Internet of Things, really, I think in those early days, really what people were talking about was, let's take a sensor and connect it to the network and take that data and process it somewhere else. And as you say, pretty quickly, it's like, okay, well, security matters. You can have billions of them. You really need to worry about making sure they're secure. So, well, we need more performance for that. Should there be a cryptography accelerator in the chip? Well, how much silicon can you afford? Fortunately, silicon manufacturing is getting better and better and better all the time, so you can suddenly put more and more. So, and then you get to this tipping point where you've got enough performance in this tiny device that suddenly, well, that stuff that you do in the cloud, which effectively has infinite compute performance, infinite memory, infinite storage, well, there's now enough performance down on this tiny thing that we can start thinking about doing some of the processing work down here. And then if you start doing some of the processing work down there on the very far end point of the network, you can start thinking about, well, how much data do I actually have to transmit? And if I get that to a minimum, well, now the energy efficiency goes up. So that sounds a lot better. So again, we've seen this kind of advancement in underlying technology capability, leveraging advances that were made somewhere else in the cloud. You know, people can experiment all day long. It's very, very inexpensive to do so. And suddenly it all kind of comes together and you go, okay, well, I can now do so much more on the edge. Let me do that. And as people have started doing it, again, you've got this virtuous circle of, well, now I've done some more. How about if I could do that? Or we've just learned that. Why don't we try and enable that capability? And again, it all kind of reinforces itself.
And this has been this entire trend of TinyML machine learning, where we brought advances in machine learning for the cloud and applied them to microcontrollers and microprocessors. And I remember very clearly, I think it was with one of Mike Muller's keynotes, when Mike was talking about both little data, remember the little data, big data days, and at the same time, he was talking about how Moore's law has a long way to go in microcontrollers. And so looking at the ARM roadmap 6 years ago, the amount of compute was just exploding with new generations of the architecture, new extensions to the architecture. And I remember Jan and I sitting down over a beer and going, what are we going to do with all this compute? It's like having a party. I'm like, what are we going to do with all this beer? It's like, there's just so much compute. The traditional stuff that we're doing, cryptography for IoT, some data processing in DSP, aren't even hitting the tip of the iceberg with what's possible. And this is what got us starting to think about, well, why don't we bring these machine learning toolkits from the cloud and apply those to microcontrollers and microprocessors? And that kicked off a lot of really interesting work around machine learning.
Yeah, no, I think one kind of moment along that journey was a sort of realization that with these technologies, with machine learning and sensing and everything, you can do more things. Well, you can do a lot of things with that people didn't initially think of. Yeah. A lot of the kind of AI in the cloud stuff, was around image recognition, facial recognition. You got these kind of tool, software platforms for storing all your photos that would spot your grandmother, and you go, well, that's weird because I've never tagged her in a picture, but ooh, okay. That's kind of what it grew up. But suddenly, you've got this sensor and you've got this high performance processor, anywhere. You can start going, well, okay, well, how warm's the room? Should we cool it down? Is there anybody in it? Why don't we turn the heating off? And people just start thinking of these new use cases, which again, then people go, okay, well, now how do I program that on this tiny microcontroller that costs next to nothing? I need a better programming environment for that. And I think that's what Edge Impulse is really, that's the problem that Edge Impulse is really solving. How do you enhance the productivity? If somebody wants to build an application on the edge, taking advantage of all of this compute performance, all of this learning that's gone on in the cloud, how do I now take it down to the tiniest device? Because there's still a lot of, the underlying math is pretty horrendous. But if all I want to do is bring some application to life, I don't have to worry about all of that. I want my productivity to be enhanced so I can leverage all of this great technology.
And we're seeing this collision of data from real industries that can solve very high value problems. And I think that's the really interesting thing about machine learning in the edge. It's no longer about just about the compute or just about the sensing or about the IoT infrastructure. It's actually about using data to solve major problems in industrial systems, manufacturing, medical and wearable devices like this Oura Ring that I'm wearing. We can solve incredible high value problems with data and ML. Where do you see some of the interesting opportunities for machine learning in the enterprise?
Yeah, fundamentally what you're looking for is insight, right? Sampling data and doing some analysis on it, that's one thing, but you want some actionable insight from that. Whether it's in the case of a medical device, the Oura Ring is really cool. How well did I sleep last night? What is my overall state of health? Lots of innovation going on in that. What can I tell by sampling the surface of my skin? And it could be, am I about to have a seizure? I've seen an application on that. What's my overall state of health? Just so much that you can glean from that. And I think that's going to be an area where we get some really interesting research done But again, it's about turning that data and using that technology for something that is actionable, something that really delivers value. And across pretty much every industry, you mentioned industrial, is my machine going to break down? Can I detect wear in it and order a spare so that when it gets serviced, the person turns up with the right equipment, the right tools, and the thing's taken out of action for a short period of time. Just that on its own, there's just so much money that could be saved and so much greater efficiency that can be created in the world. You go to agriculture, whenever I go to the UK, up in Cambridge, there's lots of farming that goes on around there. So you see these, big pieces of farming equipment spraying the field, and I'm kind of looking at going, I wonder if all the plants need all of that fertilizer or whatever it is they're spraying on it. And you see water evaporating, and you think, okay, well, if I can monitor the state of the plants, if I can monitor the moisture in the soil, you can get a lot more precise about all of that and waste less. So, I just see endless possibilities for driving insight, driving real value, creating greater efficiency, and then just learning more, getting more insight about what is going on in the world that will create new business opportunities and make the place just much more efficient.
Exactly. I mean, this is what we see driving this entire industry of edge compute going forward, is solving these kinds of high-value business problems, applying the combination of data, edge compute, machine learning where appropriate. I think this is really going to be a game changer for the next decade or two of the silicon industry, driving workloads in ML.
Oh, absolutely. I mean, the devices are going to get more sophisticated. You've got this flywheel going of people going, well, I used to code in this very kind of linear way. Well, now I can just learn from the data. Yep. How can I apply that? What else can I do? I think we're at the very early innings of how we're going to see these technologies used.
Data-driven engineering is how I like to think of it. All the way, we have to kind of reschool how we teach electrical engineers and computer scientists how we solve problems, not just with code, but with kind of data and machine learning techniques as well.
Yep.
No, very interesting. Now, one question we get often from customers is, well, do I really have to deploy all the AI in the cloud? Or does it have to be right down at the sensor where the data is happening, or somewhere in between? And it's kind of interesting how we've almost polarized the industry and going cloud versus the edge. You have to choose one or the other. How do you see this distribution of machine learning and compute capabilities across this whole spectrum of compute?
Yeah, well, I think that polarization comes from the way that we've thought about networks, right? For pretty much ever. It's been about connecting one thing to another thing, and in between is a very, very sophisticated kind of routing algorithm that takes the data from here and connects it to there and vice versa. But that is changing. We are seeing with the advent of 5G the ability to connect way more things to the internet than we ever could before. We're seeing compute move out of the cloud and closer to where the data is being collected in kind of server-sized capacity, so servers sitting at the edge of the wireless edge of the network. And then we've got more intelligence in the devices themselves. So, to this question of where should I process my data, I mean, one size doesn't fit all. It's going to come down to the particular application. But I think there's a really interesting future where some data is processed in the cloud, some's at the edge of the network, some's on the endpoint itself. You may learn things from multiple devices here. You may want to send some learning back. You may want to pick up some learning that happens somewhere else. So you've got this network, this intelligent network where data can move around. And kind of, answering the question, well, where is my application? Well, it's kind of everywhere in that network, which is going to, introduce some new challenges in terms of programming, data management, security, lots of things. But I think the potential for that just changes, again, how we can think about deploying applications.
Deploy machine learning where it's appropriate, where you have the data. Deploy it there, no matter where it is in the network. I think that's great advice. We've often talked about tech for good, something that's really dear to my heart. And I remember in my time at ARM, I was always impressed how people on the ground, everyone, engineers, managers, execs, kind of did their part to do something that mattered with the technology. And I always saw it as like ARM technology being used to solve real problems. And I found that to be really inspiring. And what we did at Edge Impulse was kind of codify that. We tried to take that tech for good that we learned at ARM and put it in our core culture that we teach everyone. That it's your job to apply our machine learning technology to help people, nature conservation being one of the things that we work a lot on. In your ARM times, what did you find to be the most inspiring things that you got to help out with? And what kind of advice should we give industry executives to make use of tech for good in their own business cultures?
Yeah, it's great to hear that you have that codified in the foundation of the company, because it is really important. And at ARM, what we saw was huge impact from what we did. Mobile phones. When I joined the company, I think the CEO was the only person that had a mobile phone. And now, I mean, billions and billions and billions of people have it.
That big.
Huge thing. Battery lasts about 10 minutes. But now, everyone's got them, and you can go to countries all over the world, and not just people aren't just playing games on them. It has enabled connectivity. It's enabled people to get access to information that they couldn't have before, and it has helped increase the quality and quantity of life the world over. And that is amazing impact. From sitting in a converted barn, knocking out code, to impact like that is really quite phenomenal. And then that kind of sense of what we're doing creates impact has really grew up with the company. So, seeing people take this technology, seeing people with increasing access to higher and higher performance, lower power technology, is in itself quite inspiring. And so what we wanted to do was really to encourage that, to encourage our people to get involved in some of these great projects that you see, where people are taking these sensors and working out where endangered species are. I've seen examples where rhinoceroses are getting tagged, for example, and the area is geofenced, and they're using it to track the habits of these creatures. We're seeing technology being used to listen out for the sounds of illegal logging in the rainforests, to help preserve that. So these people get all these great ideas, and again, if we can enable them and kind of then get out of their way and let them invent and let them create, then that's really, really impactful. And I was really proud of how people in ARM kind of resonated around that and wanted to get involved. It was just great to see. So great to see that you share that. And I think to your question about how should people think about that when running their business, especially in today's society, businesses are being looked at increasingly to play a positive role in the world. Right? Business isn't just about making money on behalf of your shareholders. You better be doing something good for the world. And I think as it comes to technology, there's a role for technology to play in addressing all of the world's biggest issues. And so I think for any particular company, it's about finding something that fits with what you do as a company, not bolting it on the outside, not having the ESG department that goes and does these things and produces a nice, colourful report, but actually really fundamentally making it part of what your company does and finding the projects that are going to then resonate with your people. Because again, I've seen it so many times. People would come up to me and say, "Oh, I'm really proud of what we're doing over here." And you go, "Oh, okay, that's fantastic to hear." Who'd have thought? But increasingly, it's becoming really, really important across all companies.
Thank you, Simon, for joining me on the first ML on the Edge show. Hugely appreciative. Thank all of you for watching, and stay tuned for next month.